I'm going to take the derivative of both sides, okay? And the formula for the derivative of arc sine is u prime over, and I've memorized this, the square root of 1 minus u squared. All right, now this is just a plug-in, but you got to plug it in right. So you determine that this is your u. Okay, from your u, you get two pieces of information. One, you get u prime. The other piece of information is u squared. Okay, guys, there is no information called u prime squared. Is everybody good with that? That's what students do wrong, because they confuse it with arc length. Okay, so what is u prime going to be? If this is u, what's my u prime? 1/2. If this is u, what's my u squared? X squared over 4. And then it's just a plug-in. So this u prime is really 1/2, but remember, fractions on the top can slip down. So that's going to be 1/2. This u squared is x squared over 4. So my answer is 1 over 2 times the square root of 1 minus x squared over 4. Is everybody good with that? Okay. Now what I'm going to do is I'm going to simplify this, because when they give you a problem, it's usually simplified. Okay, so I'm going to simplify this. And what I'm going to say is I want to get rid of this 4, because you've got a fraction and a fraction here. To get rid of this 4, what I'd really like to do is multiply this by 4. Do you agree with that? And the 4 needs to be inside the square root. Okay? So to multiply this by 4, what I'm technically doing, see if this makes sense to you. What I'm technically doing is I want to multiply the bottom by square root of 4. Right? Because multiplying the bottom by square root of 4 will let that 4 go into the house, so to speak. Okay? But if I multiply the bottom by square root of 4, what do I have to do in the top? Multiply that by square root of 4, right? And if I do this, square root of 4 over square root of 4, are you guys okay if I say that this is actually 1? You okay with that? Okay? So this will be 1 over the square root of, now I can move this into the house because they both have houses, right? So 4 times 1 minus x squared over 4. And the way that's going to help me is I can distribute this 4 and get rid of the fraction. So this would be 1 over the square root of 4 minus x squared. Okay? So what I've done is I've said that the derivative of arc sine x over 2 is equal to 1 over the square root of 4 minus x squared. And notice, if you go look at your formula, okay, your formula says it's u prime over square root of 1 minus u squared. But in my answer, I have no 1. You guys see that? I have no 1. I mean, I did have a 1. The 1 was over here, but I simplified so that there's no more 1s here. So what we're going to do today is we're going to go backwards, okay? And when we go backwards, what we're going to say is, if this is a derivative of this, then that must mean that the integral of 1 over the square root of 4 minus x squared dx must be equal to arc sine x over 2 plus c. That must be the answer. Okay, and that's what we're going to do today. Okay, are you ready to do it? Okay, let's do it. So guys, I'm going to do it, and so you might want to put this in your notes rather than your warm-up, okay, just so you can see how this works. But I know what the answer is going to be. Okay, I know this is the answer. So let me just work this and see if I can get this as the answer. Okay, on your test, you'll be given, a problem that looks like this. Okay, and you know U substitution. Okay, so what you always want to do is do U substitution first. Okay, and so U substitution would look like this. You'll say, well, U is equal to 4 minus x squared. So therefore, the derivative is equal to negative 2x. And therefore, dx is equal to negative du over 2x. All right? You substitute two things. What two things do you substitute? Do you remember? Your dx and your u. So that means this must be equal to 1 over the square root of u times negative du over 2x. And we always ask ourselves the question, do our x's cancel out? Do they cancel out? No, they don't cancel out, which means I have to do something else, okay? Now, I got to tell you, even though we know this is an arc sine, we know we have to do something else, remember, on your test, you're not going to be given the answer, okay? So you always have to try regular U substitution first, okay? So always try regular U substitution first. Now, when you know your x's don't cancel out, you say, you know what? Then I must have picked the wrong U. Let me go back and see, maybe I can do something else with this, okay? If I pick the wrong U, instead of picking u as this whole thing, okay, if I think that this might be an arcsine, arctangent, or arcsecant problem, then what would this answer be? So at this time, what I'd like you to do is go pull out your pink sheet, please. Okay, the cool thing is, okay, that we're only going to do the integral when the answer is arcsine, arctangent, or arcsecant, okay? If you take Calculus 1 in college, they could do more, okay? But AP says these are the only three we have to work with, okay? And I want you to look at these formulas. There's not a 1 here. You see how there's not a 1 here, okay? When you took the derivative on this side, do you see that there's a 1 there, okay? But when you go backwards from the antiderivative, there's no more 1. Just like when we did it, we got a 4, right? So there's not a 1 there anymore, okay? It could be a 1, but it doesn't have to be. And now they call it some constant. So I just want to make sure you understand. A represents some number. U represents some x function, some function with x in it, with respect to x, okay? And you have to have a square root. So in order to know if it's possibly an arcsine problem, arcsine integration problem, you've got to have something that looks like this. You've got to have a square root with a number minus x something. Okay, you got to have that. If you have this, if you have f of x minus a number, okay, that is not the same thing. Is everybody good with that? It's got to be exactly like this to make it an arcsine problem. Okay, let's look at this problem. To see that it's an arctan problem, you got to have what? A number plus a function. Does it have a square root on it? No. Okay. If you have something like this, you can say, well, maybe it's an arctan problem. Maybe not, but maybe it is. Okay. And if you have something like this, that is not an arctan problem. Is everybody good with that? It's got to fit this kind of skeleton exactly. Okay. Now I got to tell you, make sure you understand this. This actually is the same as this, right? Because commutative property, right? So if they're switched, it is possibly an arctan problem. And then over here, what you have to know is this is going to be some sort of f of x minus a number. It's got to be in a square root, okay? And this number sitting next to it must be, how do I say this? If this is f of x squared, then this must be the square root of whatever this is. The number sits here, okay? Because this is u and this is u squared. And if you have something that looks like that, then this is possibly an arcsecant problem. Okay, so looking at these three things and looking at the problem that we want to do, we know that the regular U substitution didn't work, okay? This is actually the square root of a number minus an f of x. Does that match any one of our possibilities? Yes, it matches the arcsine, right? So what I do here is I write this is equal to arcsine u over a plus c. I just write what's on my pink sheet, okay? Maybe it's an arcsine u over a plus c. Maybe not, but maybe it is. So let me just write that just in case that's what I'm thinking it might be. Now I want you to notice when you memorize this, because you're going to need to memorize it, do you notice that this has a 1 over a, the arctangent, and the arcsecant has a 1 over a, but this one has no 1 over a, okay? And that's a common mistake that students do on the test. They make this have a 1 over a, it doesn't. So if you think that it's an arcsine problem, please don't put a 1 over a here, okay? The other big difference is that the secant one has an absolute value on the u and the other ones don't, okay? But otherwise, it's pretty easy to memorize, okay? So let's go back here and I say, okay, maybe it's an arcsine problem. If it's an arcsine problem, all I'm really doing is I'm changing my u. Originally, I thought u was equal to 4 minus x squared, but now it's different. Now, this is my a squared number, and this is my u squared, right? According to my formula. If a squared is equal to 4, then what's a equal to? 2. And actually, when we do these, we only take the positive a and the positive u. Okay, just letting you know. You don't need to do plus or minus. If u squared is equal to x squared, then what's u equal to? X. Okay, now we're doing the same thing. All we did was we redefined what u was. And in this situation, because we think it's an arcsine problem, we also have a variable called a. All right, then you do the same thing. You take the derivative of both sides. So the derivative of u is equal to 1. You solve for dx, so dx is equal to du. And you substitute two things. You substitute your dx, and you substitute your u. It just turns out u here is u squared. Okay, it doesn't matter. We're going to put in what the value of x squared is in terms of u. Okay? So if I substitute that, what I get is 1 over the square root of 4 minus, okay, x squared is really u squared. Okay, so I'm going to put u squared there. Dx is really du, so I'm going to put du here. And I ask myself the question, do my x's cancel out? Do they cancel out? Yes. If they do, it is an arc sine problem. Okay? So this answer is going to be equal to the arc sine of u over a plus c, because my x's cancel out. So let me, before I put the answer in, let me backtrack, okay? Let me backtrack and let's talk about what we did. When you get a question on your test, the first thing you do is you'll test the regular u substitution, okay? U equals a 4 minus x squared. If your x's don't cancel out, then you say, okay, maybe it is, one of those arc sine, arc secant, arc tangent problems. That means you have to redefine your u. And you redefine your u according to the formula that you've memorized, okay? Do the whole thing again, u substitution, substitute your dx and your u, and you get to this stage, and then it's really just a plug-in. This is arc sine, your u is what? X, your a is what? 2 plus c. Did I get the answer that I thought I would get? Yeah. Does that make sense? So I've worked backwards, and the integral of this was arc sine x over 2. All right. So I'm going to change this a little bit. What I'm going to do is I'm going to take this same problem here, the same integral of 1 over square root of 4 minus x squared, and what I'm going to do is I'm going to call it x over the square root of 4 minus x squared dx. Okay? So same problem. You guys see it's the same problem? But I'm going to put an x up here. Okay? So I know that, I don't know, why did I x that out? I'm not sure. Oh, because we didn't know that, but now we know it. Okay, if I have this problem, let's see if you can do it. What would your u be equal to here? 4 minus x squared, right? The derivative here would be negative 2x. Okay, solve for dx. This, you guys know how to do this. This is just regular u substitution. Okay, dx equals negative du over 2x. And then you substitute two things. What two things would I substitute? My dx and my u. Okay, let's put that in. That would be the integral of x over the square root of u times negative du over 2x. Then I ask myself the question. What question do I ask myself? Do my x's cancel out? Do they cancel out? Why, yes, they do. So this answer would be, they cancel out to 1, right? Pull out your scalar. So I have negative 1/2, the integral of du over the square root of u. At this point, after the x's cancel out, this should be an easy reverse power rule, or it should be something on my pink sheet. Is it an easy reverse power rule? It is if I rewrite it. What can I rewrite this as? Yeah, u to the negative 1/2. So then what you do is you add 1, divide by 1/2, but if I divide by 1/2, I'm really multiplying by what? 2. Okay, these 2's are going to cancel out, so I get negative 1 times u to the negative 1/2 plus Charlie. Okay, and that is my answer. Okay, but it's the wrong answer. Why is it the wrong answer? You need to plug your u back in. Is this negative? It's a positive. Sorry. This is negative 1 times u to the positive 1/2 plus c. Okay, if I substitute my u back in, what's u in this problem? Yeah, so it's a square root of 4 minus x squared plus c. And so that is my answer for this problem. Okay, so I'm just going to tell you, the answer to this problem was an arc sine problem answer. The answer, when you just put the x in, turns out to be an easy u substitution that you're used to. Okay, so do you see how your test is going to be kind of tricky? Do you see that? You're always going to try the easy u substitution. If the x's don't cancel out, then you guys say, well, maybe I need to change my u's to make it like an arc sine or arc secant or arc tangent problem. Okay, let's go to this problem right here. So this is another warm-up problem. So I'm going to do the same thing that I did on the last problem. I'm going to work this with the derivative, then I'm going to work backwards on it and see if I can get the right answer using u substitution. All right, so this is your second warm-up question, and it said take the derivative of this. Okay, so what I want to do is find y prime. If I take the derivative of both sides, do you agree that if I took the derivative of this part right here is just a scalar? You guys okay with that? So I'm going to pull the scalar out, and I'm just going to take the derivative of the arctangent. Are you guys good with that? I'm going to take the derivative of both sides. So this is going to be equal to, I pulled the scalar out, so I have 1 over square root of 2. And the derivative of arctangent, what's the formula? U prime over what? 1 plus u squared, or u squared plus 1. Okay, it means the same thing. All right? And again, guys, I need to find my u. So this right here is my u. If this is my u, I need to find two things. I need to find u prime, and I need to find u squared. All right? If this is my u, what's u prime going to be? 3 over root 2. If this is my u, what's my u squared going to be equal to? 9x squared over 2. All right? And guys, it really is just a substitution problem. This u prime is now 3 over square root of 2, but remember fractions on the top slip down. Okay? U squared is really 9x squared over 2. Okay? Now, what students don't realize where they go wrong here is this down here in the bottom, denominators by themselves are quantities. So there really is a parentheses here. Okay? So, do you see the square root of 2 times the square root of 2 is just 2? Okay, so this becomes 3 over 2 times 1 over the quantity 1 plus 9x squared over 2. How do I get rid of this 2 down here? Yeah, usually if you distribute, it just goes out by itself. So this will be 3 over 2 plus 9x squared. And there's your answer. Okay? And what does this mean? This means that if the derivative of this arctangent is equal to this, then that means, see if this makes sense, that means that the integral of 3 over 2 plus 9x squared dx is equal to arctangent 3x over square root of 2 plus c. Okay? So we're going to do that. So now you're done. You're pretty much done with your warm-ups. If you want to write this in your warm-ups, that's fine. But what I'm going to do is I'm going to work this left side with you, and I'm going to show you that this answer is this arctangent problem. Okay? So let's do it together. All right. So if you have this on your test, the first thing I would do is I would say u is equal to 2 plus 9x squared. You always do regular u substitution first. Okay? Now, that means du dx is equal to 18x. You agree? And that means dx is equal to du over 18x. Okay, I'm doing regular u substitution. All right? You don't know that it's an arcsine, arctangent problem. Okay, you always just do regular u substitution first. And then you replace two things. What two things do you replace? Your u and your dx. So let me go replace them. I'll get 3 over u times du over 18x. Okay? Then I ask myself the question. What question do I ask myself? Do my x's cancel out? Do they cancel out? No. Back to the drawing board. Maybe my u is something else. Okay? Now, let me just add this in here to make sure you understand. Had my problem been this, had it been 3x over 2 plus 9x squared dx, which it wasn't. But what I'm going to do is I'm going to add an x here. Had this been 3x, okay, and I had made this my u, okay, do you guys see that this would have been 3x over u times du over 18x? Would my x's have canceled out here? Yes, okay. So you got to go through the u substitution because it might work and you might not have to do the arc thing, okay. On this side, your x's would have canceled out. This answer would have been 1 over 6, I think, right? 1 over 6. What's the integral of du over u? Ln of u, right? So this would be 1/6 ln of u plus c, and that would be the answer had there been an x here. Okay, well, it's actually the wrong answer. How do I make it the right answer? Yeah, plug in your u. Your u here was 2 plus 9x squared plus c. Okay? So I just want to make sure you guys understand. Just a subtle difference. Putting this x here turns a whole equation, like a whole antiderivative to a different answer. Taking the x out, okay, it turns out the x's don't cancel out here. So what I have to do is say, you know what? I think I can change my u here. Let me think. This might look like a what? And so let's just go look at this problem. This might look like this is a number plus an f of x. Guys, which one on my arcsine, arctangent, arcsecant is a number plus f of x on the bottom? Tangent. Might be a tangent. If it is a tangent, what would my u be? Well, let's think about it. If it is a tangent, this is my a squared, right? This 9x squared would be my u squared, okay? That means a is actually equal to what? This is kind of funky. Square root of 2, right? Only take the positive numbers here. My u would be, what's the square root of 9x squared? 3x, okay? Then you just work it down. If u is equal to 3x, the derivative is equal to 3, so dx is equal to du over 3. Okay, and we're basically doing u substitution. Okay, we basically just changed what we thought our u was. Okay, you replace two things. You replace your u and you replace your dx. So let me circle it. There's my dx. And guys, my u here, do you see my u is a 3x? So actually, I'm going to replace the u squared here. Okay, so when I rewrite this problem, let me just delete this. When I rewrite this problem, what I'll get is an integral of 3 over 2 plus u squared times du over 3. And then I ask myself the question, do my x's cancel out? Do they cancel out? Yeah, they're not even there. Guys, if they cancel out, this is an arctan problem. Does that make sense? Because I assumed arctan by making this a squared u squared thing. Okay, so this is an arctan problem. Okay, so what that means if it's an arctan problem is this answer is 1 over a arctangent u over a plus c. Okay, and then it's just a substitution problem. Let me just make sure, hold on. Do you see the 3's cancel out here? 1. Okay, so I didn't mention it, but it needs to actually look exactly like your formula in your pink sheet. Okay, so it needs to have a 1 here. If it doesn't have a 1 and it's a scalar, pull the scalar out. Does that make sense? Pull the scalar out and then just remultiply it back in. Okay, but this has a 1, so this looks exactly like your pink sheet. Guys, I know your pink sheet has an a squared here. The a squared just represents some number, and that is some number. Okay, so here all you do is do substitution. So you have 1 over a. My a here is what? Square root of 2. Arctangent. What's my u here? 3x, right? A is root 2 plus c. And here's my question. Is my answer what I thought it should be? Uh-oh. Uh-oh, it's not. Sorry. This had a 1 over square root of 2, right? I just didn't copy it. I didn't copy it right. Okay, it had a 1 over square root of 2. It was this part right here. Okay, so it was exactly what I thought it should be. Okay? Okay. I'm going to do this problem right here. We've already done these two problems here, so just FYI, I'll leave these notes up for you guys in my slides. But this answer here, we just did this. We did this problem. This was the 1 over square root of 2 arctangent. I don't remember anymore. Was it 3x? I don't remember. Was it x? 3x over square root of 2 plus c. So that was this answer. This answer here was the 1/6 ln of u plus c. We've done this, okay? And notice these all have the same denominators. I want to do this problem with you guys, okay? So if you had a problem like this, 18x minus 5 over 2 plus 9x squared on your test, how would you approach this? Okay, and the problem is you just make one subtle difference that changes the answer to this integration. So let me say that for this problem, let me try and say that u is equal to 2 plus 9x squared, okay? I always try u substitution first, okay? When I do that, what I get is dx is equal to du over 18x, and I say I substitute two things. What two things do I substitute? My u and my dx. So let me rewrite that. That'll be 18x minus 5 over u times du over 18x. Here's the big question. Do my x's cancel out? No. No. They look like they might, but guys, you have to use real algebra, not that fake stuff, okay? And this does not cancel out, okay? Make sure you understand that, okay? So since this doesn't cancel out, you have to say, okay, back to the drawing board then, okay? Maybe this is an arctan problem, okay? So if it's an arctan problem, what I do is I redefine the u. So I say, okay, well, maybe this is a squared, maybe this is u squared, okay? So that means u squared is 9x squared, okay? That means a is equal to square root of 2, u is equal to 3x, okay? Guys, once you get your u, you do what you always do. You take the derivative and you solve for dx, all right? So you substitute two things. What do I substitute? My u, but in this case it's u squared, okay? and my dx. Let me go ahead and substitute that. That would be 18x minus 5 over 2 plus u squared times du over 3. Okay, I'm substituting this dx here, du over 3. Then I ask myself the question, do my x's cancel out? No. Okay, now I'm in trouble. The regular u substitution didn't work out. This problem, which I thought was arctan, the x's are not canceling out. Now I'm in trouble. Guys, okay, when the things don't work out, what you want to do is split it up. You split up, okay? When relationships don't work out, you always have the option to split up, okay? So I'm going to split this up. Are you ready? Isn't this the same as 18x over 2 plus 9x squared plus negative 5 over 2 plus 9x squared? Aren't they the same things? It was actually a buy one, get one free problem, okay? You just didn't see it right away. But you could see that the u substitution didn't work out, okay? So what happens here is this actually it's actually two different integrals. So let me add an integral here. This is an integral here, and let me put a dx here and put a dx here. You really need the dx's so you can do the u substitution, okay? On this side, I don't know if you guys see it. This is just a regular u sub problem, okay? Right here, make your u equal to 2 plus 9x squared. Du dx is 18x. Dx is going to be du over 18x. You replace two things. You're going to replace your dx and you replace your u. So over here, you'll get 18x over u times du over 18x. Okay, I'm just working this left problem. Okay, remember, it's a buy one, get one free problem. Okay, so you thought you got to do one problem, but, oh boy, you get to do two. So I'm just working this first one first, okay? And so on the first one, do my x's cancel out? Yeah, as a matter of fact, they do. Actually, the 18s cancel out too, which is just a bonus. This becomes the integral of du over u. Is this something that's an easy reverse power rule problem or something on my pink sheet? It's something on my pink sheet. This is just ln of u plus c. And ln of u plus c, place your u back in. That's 2 plus 9x squared. And I'll add the c in a second, because whatever answer I get, I need to add with this answer anyway. Okay? On this side, when I make this my u right here, I'll have negative 5 over u times, it's the same math problem over here at the black here, u equals 2 plus 9x squared. My dx is going to be du over 18x, so this would be du times 18x. And my question will be, do my x's cancel out here? No. Then I go back and I say, hey, maybe I'll make the u something else. Maybe make it a, what kind of problem might it be? An arctan problem. Okay, so if I make it an arctan problem, a squared is equal to 2, u squared is equal to 9x squared. That means a is equal to the square root of 2. That means u is equal to 3x. Just take the positive values. Once you get your u, work down u just like the u substitution problem. Du dx equals 3. Dx equals du over 3. I replace two things. I replace my u. I replace my u, which is actually u squared here, and I replace my dx, all right? When I rewrite this, what I get is negative 5 over 2 plus u squared times du over 3. And I'm assuming it's an arctan problem. If it is, my x's better cancel out. Do my x's cancel out here? Why, yes, they do. So this becomes an arctan problem, but be careful. You got to make this like your pink sheet. And your pink sheet has a number 1 up here. It doesn't have this negative 5/3. Does that make sense? So what you have to do is pull out the negative 5/3 as a scalar. So I'll pull out the negative 5/3 as a scalar, and I'll have du over 2 plus u squared. Okay, now this should be something on our pink sheet. This right here is on your pink sheet. Okay, so that means that the integral of this is actually negative 5/3 times, okay, what does my pink sheet say that the integral is for the answer is for the integral of an arc, where the answer is arctan. 1 over a arctangent u over a plus Charlie, right? So in this problem, this was negative 5/3 times, what was my a in this problem? Square root of 2, arctangent. What was my u in this problem? 3x. My a is square root of 2 plus Charlie. And so what I do is I combine this answer with this answer. Does that make sense? You just add them together. That's your answer. Okay. You could multiply the 3 and the square root of 2 together. It's not a big deal. All I do is just drop out this dot. You could rationalize, but I wouldn't do that because you introduce some more error. And AP doesn't require you to rationalize, and neither do I. Okay, but you could rationalize if you wanted to. Did you like that problem? If you look at your homework, there's a problem number 7. Do you guys see on number 7 that the exponent on top is bigger than the exponent on bottom? What are you going to have to do first? Long divide. You're going to long divide, and you'll end up with 2 buy 1 get 1 free problem. Okay, so just FYI. And also FYI, this worksheet is not all arcsecant, arctan, arcsine problems. Some of them are just regular U substitution. So you'll have to figure out which one is which. I'd like you to look at number 5 with me. If you look at number 5 on your homework, okay, you have this problem that looks like this. 1 over x, the square root of 4x squared minus 1 dx. And I'm just going to give you a big hint. You can try U substitution. It's not going to work out. But you can try it and find for yourself that the x's are not going to cancel. But I want to show you this. This is an f of x minus a number square root. Do you see that? On your pink sheet, which is it closest to? Arcsecant. Do you see it? Arcsecant. But arcsecant requires that if this is, whatever this is, if whatever this is squared, that this sitting next to it is the square root of it. Does that make sense? Okay, so this doesn't totally fit the arcsecant skeleton, except what is the square root of 4x squared? Well, then you really just want a 2 here, right? Well, how could you make this problem a 2? Can't I just multiply by 2 over 2? Isn't multiplying by 2 over 2 the same as multiplying by 1? Okay, so guys, on number 5, just change your problem to this. Okay, and it'll turn out to be an arcsecant problem. Okay, do the same things that you usually do. This will be your u squared equals 4x squared. This will be your a squared equals 1. So your u here is going to be 2x, your a here is going to be 1. And then you're going to take the derivative, du dx equals 2, dx equals du over 2. You substitute, okay? When I substitute here, I'll get 2 over this 2x. I'll actually substitute because it's part of my, does that make sense? It's part of my u squared thing, okay? So this turns out to be u. This turns out to be u squared minus 1. Your dx is really du over 2, and I'll leave it to you from there. Okay, I think from there you can figure out the rest of number 5. I also want to do another problem with you. We had this problem on our warm-up that we've already solved. The answer was, and I'll let you just refer to your warm-up to look at this, but the answer was arc sine x over 2. Okay, we've already done that. Okay, on the back of your homework, you've got definite integrals. Okay, so when I solved the integral of dx square root of 4 minus x squared, that was equal to arc sine x over 2 plus c. Okay, when you have definite integrals, all you do is you take this answer that you have. Remember, it's the first fundamental theorem of calculus. All you do is you plug in 1, you plug in 0, and you slap a minus sign in the middle. Do you remember that? Okay, so on the back side, don't let these limits fool you. Just do the integral just like you did the front side. Okay? Then set it up like this. Make sure you have x's here, not u's. If you have u's here, then you need to change these to u's. Does that make sense? Okay, so make sure these are x's if you're going to put in, or this is an x, so this is an x equals, okay? Then what you're going to do is first you plug in the x. I'm sorry, first you plug in the 1. Then you plug in the 0. Then you slap a minus sign in the middle. Okay? And what you're going to do is this is going to be like what you did for homework yesterday. Okay? You solve for arc sine of 1/2. What is arc sine of 1/2? Guys, remember, arc sine of 1/2 is the same as some angle, right? It's an angle answer. It's the sine of what angle gives you a sine value of 1/2. Okay, so what angle will it be that gives you a sine value of 1/2? Think about it. Yeah, it's either here or here if it's an arc sine problem. So this is going to be pi over 6 minus. Same problem here, guys. This is going to be the sine of what angle gives you 0. What angle, the sine of what angle gives you 0? Well, the sine of 0 is here and here if the sine value is 0. So which angle is on this side? 0. So your answer here would be pi over 6 had this been your problem. But your problems vary on the back, okay? And then there's one other thing I need to teach you, okay? This problem is actually an arctan problem in disguise, okay? If you take the derivative of this, u equals, take u and then take the derivative, what's going to happen, I'll just let you know, is that your x's are not going to cancel out. This will be 1 over u times dx or du over 2x minus 4. Okay, your x's are not going to cancel out. Okay, so what you need to do is think about this and say, okay, what else can I do to this problem to make it work? And what you do is you turn this into an f of x plus number problem. Okay, and to do that, what you do is you say dx is x squared minus 4x plus, you leave a blank, plus 7. You rewrite this problem, but you leave a blank. Okay? And when you complete the square, what you do is you grab this coefficient. First of all, this coefficient has to be 1 to complete the square. Okay, so make sure this coefficient is 1 first. And then you grab this coefficient and you say divide it by 2 and then square it. So what's negative 4 divided by 2? Negative 2. What's negative 2 times negative 2? Oh, yeah, that's right. I was going to say something else, but you're right. Okay. If you add 4, you also have to subtract 4. Okay, so first of all, what you do is you find the magic number. That turns out to be 4. The magic number is always positive because you always square, to get this number. All right? Okay, then what you do is this is a completing the square. What does that mean? You can rewrite this as x minus 2 squared. Okay, it's a rewrite thing. Okay, so what happens is you change this problem into dx over x minus 2 squared plus 3. And this problem is a very nice arctangent problem. Why? Because this is equal to u squared. Okay, this is equal to a squared. That means my u is equal to x minus 2. You see that? This is kind of tricky. That means my a is equal to square root of 3. Okay? That means if I take the derivative down here, so once you get u, you want to take the derivative. So u here would be du dx equals 1. So solve for dx, dx equals du. You substitute two things. You substitute your dx and you substitute your u squared in this situation. Okay? So this will become du over u squared plus 3. Okay? And then I have to ask myself the question, do my x's cancel out? Okay, do they cancel out? Yes. And so I made this into an arctan problem. If they do, then this answer is 1 over a arctangent u over a plus c. Okay, what is my a in this problem? Square root of 3, right? Arctangent. What's my u in this problem? Be careful. X minus 2. You see that? And what is my a in this problem? Square root of 3 plus c. And there is your answer. Okay? So sometimes it's an arctangent problem in disguise. And that's when you can complete the square. All right? That pretty much concludes, I think, you're ready for your homework. Good luck with that. Just remember to try U substitution first before you try all of the fancy arc stuff.